Okay, so now we're ready to move on to Pythagorean's theorem, and we're going to do application problems here. Okay, so remember from the other side, A and B are the legs of the triangle, okay, and C is the diagonal. It's always the side that is across from the right angle. All right, remember we can only use Pythagorean theorem when we have a right triangle, meaning you have to have a 90-degree angle in your triangle. Alright, so let's look down. In order to solve these problems, we're going to have to write in some steps here because it's very important that you follow these steps. It will make solving the problem very easy. So the first step for any application problem is to read the problem. And you need to read the problem carefully because they're going to tell you in the problem how to draw your triangle. RTSQ. Read the stupid question. Now, the whole purpose of reading the problem is so that now we can draw a picture. When in doubt, draw it out. It makes things so much clearer. A lot of us are visual learners, and once you see it, then you're like, oh, I get it. It's not as hard as what you thought. But when you're reading a lot of words, I can sympathize with you because a lot of times when I'm reading words, it's like, what in the world? But as soon as I see a picture, it makes it that much easier for me to understand. Alright, so after we draw the picture, we will determine what we're solving for. And remember, whatever we don't know what something is, we use a variable. So that's going to be determine what to solve for, and that is our unknown. What is it that we don't know? And it should match up with what you read originally in the problem, okay? So they're asking you for the height of the building, and you have something at the bottom of the building labeled as unknown. That doesn't make sense because straight across doesn't measure height. Something up and down would have to measure height. Once you determine what to solve for, you will refer back to your problem to determine how to round. And we know we can get decimals for our answers for decimals. Now you have to read it carefully and look at your answer choices because on your CDA some of your answers are written in radical form, which is like what we did in our warm-up, and some of them are written in decimal form. So it's all going to depend on what type of answer they're asking you for. The same answer can be written as a decimal or as a radical. So that is going to help you determine what to do to get your answer. Alright, so step number 1 said read the problem, so here we go. We have a 15-foot ladder that leans up against a building. The foot of the ladder is 5 feet from the base of the building. How high up the wall to the nearest foot does the ladder reach? So we have a ladder, it's 15 feet, and it is leaning up against the building. So step 2, draw the picture. So this is going to be my building. Okay? We have a ladder that is leaning up against the wall. So here's my ladder. Okay? The ladder is 15 feet. And it's leaning up against the building. Okay? So that means the ladder has to be the diagonal because it is leaning up against the building. Now, the foot of the ladder, which means the bottom of the ladder, is 5 feet from the base of the wall. So if we measure to the bottom of our ladder and to the wall that we leaned it against, this has to be 5 feet. That's what it says. The foot of the ladder, the bottom of the ladder is 5 feet from the building. How high up the wall to the nearest foot does the ladder reach? So now I can determine what I'm solving for. The part of this triangle that you see in here that we do not know is the height from the ground to the top of the ladder. That's what we're solving for. So now that we have everything labeled and we drew our picture, we know what we're solving for, we can plug it in and solve the problem. So we're using Pythagorean's theorem. A squared plus b squared equals c squared. Now A is normally the vertical piece, so since I don't know what A is, we'll just plug in x. That's our unknown value. B is normally the horizontal piece, which will be 5. So that'll be 5 squared. And C has to be the diagonal piece that is across from the right angle. And we can clearly see this would be where the right angle would be. So 15 is across from the right angle. That makes 15 the C. That is the most important step, figuring out where to put the 5 and where to put the 15. And that all comes from your picture. Alright, now we're ready to solve. So we're solving this equation. We're going to use the exponents first because order of operations, please excuse my dear Aunt Sally. We don't have any parentheses, so we go to the exponents. Can't do anything with this exponent, but we can with this. This is the same thing as 5 times 5. So 5 times 5 is 25. And on the other side, we have 15 squared, which is the same thing as 15 times 15. So 15 times 15, or 15 squared, is 225. Yeah, that looks kind of not clear there, so we'll clean that up. So I'll do 225. All right. So now we're solving for x. X wants to be by himself on this side. That means the 25 has to go. So to get rid of the 25, since there's a plus sign here, I subtract 25 on both sides. Make sure that you have the same sign and it is subtraction on both sides. This cancels, which gives me x squared. And 225 minus 25 gives me 200. Now remember to get rid of the square that's on your x, because we're just looking for x over here, not x squared. Then we have to take the square root of both sides. So x equals, and let's see if this is a perfect square, which I don't think it is. Nope, I get 14.142 and some more numbers. Okay, now we have to go back to the problem and figure out where we're supposed to round. So as you normally figure this out either in the first sentence or in the last sentence. So it said, how high up the wall to the nearest foot? So to the nearest foot means they don't want any decimals. They want us to round and get a whole number. So if we round this answer, and when we round we use the squiggly lines to represent approximately 14 feet. So we would say the ladder, we have to answer the question, reaches approximately I just messed up that. Approximately 14 feet high. Okay, how high up the wall to the nearest foot does the ladder reach? The ladder reaches approximately 14 feet high. And when you enter your answers on your CDA, they will be looking for the number answer. So you would simply type in 14 feet. But when we're doing our homework and our classwork, when you have a word problem, you have to present your answer using a sentence if they gave you words. So in other words, if they give you words, you got to give them back words and answer the question. This shows me that you understand not only how to solve the problem, but but you understand what the 14 represents in relation to the problem. That is higher level thinking skills, and that is how they are going to assess you on your EOC at the end of the year. Okay? So if you have any questions, you can pause the video now and you can address your questions with Ms. Hall. Alright, so example number 2. Example number 2 is a direction application problem, and they use this a lot. They like to use this. You will most definitely probably see a problem that looks like this on your EOC at the end of the year. Alright, so here we go. Tim rode 8 miles due north, then 3 miles due east. How far to the nearest mile is Tim from where he started? Okay? Step 1 was to read the problem. Step 2, let's use what we just read to draw a picture. Alright, so we'll say that this is our starting location. Okay? Doesn't matter where you put your dot. I just put mine so I'd be able to go north and east. And actually, I'm going to need to move this over because north and east means I'll be moving to the right. Alright, so the first thing says Tim rode 8 miles due north. North means that he's going up. So, from my dot, I'm going to draw a line. Okay. Let me try to make that a little bit better of a straight line. That is not working. So I'm going to use my little tools. And we will draw a line that goes straight up. Alright. Then he went 3 miles east. Okay. So 3 miles east. East is to the right. I remember East Coast that way. Alright, and they want to know how far is he from where he started. Okay, so let's go back and let's put our labels on what we just drew. 8 miles north and 3 miles east. So east was going this way and north was going straight up. They want to know how far is he, because this is where he ended at. How far is he from where he started? So what we're looking for is the distance from where he is now to where he started. Okay, so we can obviously see our right triangle here. And this would be C because it is the diagonal or the side across from the right angle. So now we know that 8 and 3 are our legs. They are A and B. So let's plug into our formula. We know what we're solving for now. So we can solve. Alright, so A, normally our vertical piece, so I'll say this is 8 squared. B, normally the horizontal piece, so we'll say that is 3 squared equals C squared. Alright, 8 squared is 64. 3 squared is 9. And 9 plus 64 gives me 73. Alright, and that is going to be equal to C squared. Now, we're not looking for C squared. Once again, we're looking for C. So, we need to take the square root of both sides. So, C equals, now notice in this example, they did not give us any numbers as far as where to round. Well, actually they do. They say to the nearest mile, which means again, they do not want us to have any decimals. So when I write my answer out, I'm going to use the blue button, second, and x squared. In my calculator, this is what I'm putting in order to get my answer. And then I'm going to type in 73. So second x squared, 73. We get 8.54 and some more decimals. Well, the question said to the nearest mile, which means they don't want any decimals. So we look behind the 8, since the 8 is the whole number, and it is a 5. This 5 makes the 8 become a 9. So we will again use the squiggly lines because we just rounded. And anytime we round, it is not an exact answer. Okay, it is an approximate answer, and that's what the squiggly lines mean. And now we can answer the question. So Tim is approximately 9 miles from where he started. All right, and that basically is a summary of what we've just done. We've done Pythagorean theorem just using the triangles and application problems. So wrapping it up, what did you learn? I need each of you on your notes right now to go ahead and answer these 4 questions. Ms. Hall, you can pause the video to give them time to answer, about 5 minutes, and then you can unpause the video so each of the students can check their answers. Alright, so I hope that each of you made an honest effort to answer each one of the questions because it's really a summary and making sure that you understand what you're doing and why you're doing it. The Pythagorean theorem can only be used on blank triangles. Who knows the answer? Okay, so we say right triangles are the only ones that can use the Pythagorean theorem. Number 2, when should the Pythagorean theorem be used? Okay, the Pythagorean theorem should be used when you know 2 sides, lengths, and you are asked to find the length of the third side. Now keep in mind, this is only if you're given 2 side lengths with a right triangle. That is like the most important thing to remember. You cannot use this with any triangle you want to. That triangle must have a right angle. Alright, what should be done first when solving a word problem involving the Pythagorean theorem? Well, there's 2 possible answers. The first one would be our step 1, which is RTSQ, read the stupid question. Another one that you may have put is to draw a picture. Both of these are equally important, and I would accept either one of these as your answer. If you don't read the problem, you can't draw the picture, so they kind of go together. Number 4, what must be done before writing the answer to a Pythagorean theorem problem? Well, you should have put determine how to round your answer. Now, in our examples, we always rounded to the nearest whole number, and I know from experience, because I've already looked at your CDA, they don't always tell you to round to the nearest whole number. Sometimes they ask you to round to the 10th place, and the 10th place means that you get to keep 1 number behind the decimal. So if we were to round this answer to the 10th place, then we would have had 8.5. Because I only get to keep 1 place behind the decimal. That is the 10th place, 10th, THS. Okay? If they said the 100th place, then I would present my answer like you see it here, 8.54. So you must make sure that you pay attention to the wording of the problem. Presenting your answer the correct way is important because you don't want to do all of that work and then end up with the wrong answer. Okay? So that concludes our lesson on Pythagorean's theorem. This is one of the most important lessons for this unit. So please make sure that you do your classwork. Make sure you complete it. It's due before you leave class today. And then you will get a homework worksheet to go home and practice it on. If you refer to my website, sylviaanderson.weebly.com, you have examples that can help guide you on your homework. I have posted your homework with examples on the website. So the worksheet that you get in class does not have examples on it. So if you want to see the examples, you'll have to go to the website. All right? Thank you so much for being angels for Miss Hall. Please make sure that you keep up your work. I want to see everybody's grade go up, not down. Have a good day.